Please write bonding in coordination compound. So the bond between, when we talk about bonding in coordination compounds, we are talking about the bond between the central metal atom and the ligand. Okay, not the coordination entity and the counter ion. Those are like ions only. But when we talk about the bonding between central metal atom and the ligands, then these can be explained by various theories. The first and the foremost theory is valence bond theory. We call this VBT. Then we have the crystal field theory. And we also have, this is known as CFT. There is a ligand field theory. That is LFT. And the last one is molecular orbital theory. Now, we don't have to learn all of these four. We are going to look in detail in valence bond theory and crystal field theory. These two are not in your syllabus, ligand field theory and molecular orbital theory. Okay, but the crystal field theory, whatever is given in NCERT, it uses some of the conclusions also from the ligand field theory. Okay, so you don't even have to know the names of these parts, but you need to know everything about the valence bond theory. Sorry, and the valence bond theory and the crystal field theory. So write the first topic, valence bond theory. No, basically the valence bond theory, it depends on what is the hybridization and then what it detects, what is the geometry of that particular coordination complex. So for example, if you have coordination number, write this table, coordination number. Then what is the hybridization for this? And with respect to this hybridization, what is going to be the geometry of the complex? When the coordination number is 4, then you can have hybridization sp3. If you have sp3 hybridization, it will have tetrahedral structure. Now there is one more hybridization possible in 4 coordination number, that is dsp2. And this is when you have square planar. This will give you a square planar structure. When you have coordination number 5, there is an option of sp3d, which gives you trigonal bipyramidal. When you have 6, then in this you can have sp3d2, or you can have d2 sp3. Both of these are going to give you octahedral geometry. Okay, now in this, the coordination number 4, sp3 dsp2, and the coordination number 6, that is sp3 d2 or d2 sp3, these are important. Please write this down. Before moving to the valence bond theory, let us just revise what are at least the 3D series element. Okay, so which element are present in the 3D series? We have Sakti Vikraman Feconicosin. Sakti Vikraman Feconicosin. Okay. And what are the atomic number for this? This is 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. Now, you'll also write what are the outermost electronic configuration for this. So all of them have argon, that means 18 electrons are there, and then they have 4s2, 3d1. Okay. Now this will be all 4s2, 3d1. I'm just writing the S and D configuration. So this will be S2d2. This will be S2d3. This will be S1d5 because exception of chromium. Then again you have S2d5. This will be S2d6. कौन है 4s and 3d. ठीक है, ये याद रखिएगा. 4s2 3d1 करके है. 4s2 3d2, 4s2 3d3, 4s1 3d5, 4s2 3d5, 4s2 3d6, and this will be 4s2 3d7. This will be 4s2 3d8. This will be 4s2. This will be S2 and D. No, sorry. S1 and D10. This will be S2 and D10. Okay, please write this up. The outermost shell in the 3D series is the fourth shell. So if you are going to remove electrons from scandium, then you will first remove the electron from the 4s. उसके बाद you will remove if there is any electron to remove from 3D. Okay, so for example, 4s2 that will have, sorry, if you have scandium 2 plus, that will have 4s0 and 3d1. Please write these things down. No. Right, next. It is generally possible to predict the hybridization of a complex using the valence bond theory only if we know the magnetic behavior of complex. Magnetic behavior of complex. Okay. But generally speaking, not always also. Okay, so valence bond theory is of no good, by the way. Okay. But there are some cases जिसमें आपके पास वो सवाल करेंगे and they will ask you to explain according valence bond theory. But the main explanation that we are going to give will use some kind of crystal field theory also. Okay. So you are bound to use the crystal field theory always. And I will teach you how to explain things in valence bond theory using some information about the crystal field theory. But let us first of all see the first example on how you are going to on how we are going to explain things in valence bond theory. Okay.
I can scroll up.
अच्छा लिखिए. Done, guys? Those who are late, they can take a screenshot. You can take a screenshot from here only, valence bond theory. Anyone still writing? No, right? Okay, see. We have two complexes, cobalt NH36, 3 positive. Now, this is diamagnetic. What does diamagnetic means? It means there is no unpaired electron. Okay, and then you have cobalt F6, 3 negative. This is paramagnetic. This has at least one unpaired electron. This will have at least one unpaired electron. And they will give you this information. They will ask you, explain why CONH3 whole 6 3 plus is diamagnetic, but COF6 3 negative is paramagnetic using valence bond theory and all. Okay, so they will give you something like that. Now, first of all, let us use these two things, diamagnetic and paramagnetic, and tell why, and they'll explain the bonding according to the valence bond theory. So if I look at the first one, that is cobalt, NH3 whole 6, 3 positive. Okay. Now this is diamagnetic. That means there is no unpaired electron. Now, first of all, what you need to do is, whenever you are going to explain anything from the valence bond theory, is the oxidation state of central metal atom. Okay. Now, oxidation state of central metal atom, cobalt will be X plus, what will be the, tell me guys, NH3 will be what? 6 into
0.
6 into 0. This will be equal to, what is the charge in the complete complex? Plus 3, right? So X will be equal to how much? Plus 3, right? Yes or no?
Yes, sir.
Okay, now next thing, you will write the electronic configuration of cobalt. Of what? Of cobalt 2 plus. No, sorry, cobalt 3 plus. So what is the normal oxidation? Sorry, normal electronic configuration? Look at cobalt. You have 4s2 3d7. So you'll remove 2 electrons from S and 1 electron from D, right? So 2 electrons from S, it will be 4s0, and 1 electron from D. 3 electron nikalne hai aapko. So you'll remove 2 from the S, first from the S and then from the D. Why? Because 4s is what? Outer than 3. Fourth shell is outermost, right? Uske baad you have 3. Okay, so you'll first of all write what is CO3 plus. CO3 plus will have the electronic configuration of outermost electronic configuration of 4s0, and you will have 3d6. 4s0 and you will have 3d6. Now, let us make these things. One, two, three, 4, 5, big space, 5. Okay, and then we have, this is the 3D. And then you have the 4s. So 3D may we have 6 electrons. So 1, 2, 3, 4, 5, and 6. So, do you see any unpaired electron here? Yes or no? Please tell me.
Yes.
Okay. Now there cannot be any unpaired electron. Why? Because this is diamagnetic. They have said this is diamagnetic. Okay. In crystal field theory, we will understand that this is diamagnetic because of this ligand. And since it is diamagnetic, we will pair up all the electron. We will write since complex is diamagnetic, pairing takes place. So the pairing will take place and you will get Now the d electrons will be paired like this: 1, 2, 3, 4, 5, 6. Okay. Now the d subshell, जो आपके पास वैलेंस बॉन्ड थ्योरी, उसमें जो एक मोस्ट इंपॉर्टेंट पॉइंट है, दैट इज the d subshell will have empty orbitals equal to the number of coordination bond it is making. So for example, in this case, we have the coordination number is 1, the coordination number is equal to 6. So the d subshell, not the d subshell, rather the central metal atom should have 6 vacant orbitals. Okay, so please write next. Number of vacant orbital in CMA should be equal to the number of coordination number. ठीक है, अब यहाँ पे हमारे पास how many vacant orbital do I have? Tell me guys. How many vacant orbital can you see?
3.
3, right? 3d and 4s. Now where can we get the next vacant orbitals? Those 3 more vacant orbitals will be the 4p orbital. आप पूछिएगा 4p कहाँ से आया सर? I will say that if you have the fourth shell, then there will be 4p also. आपको 4d चाहिए तो 4d भी मिल जाएगा. If you want 4f, 4f भी मिल जाएगा, because we have entered the fourth shell. And in fourth shell, even if it is now empty, है ना? Fourth shell कहाँ से मिला? Because cobalt was having 4s2 and 4s2, so 2 इलेक्ट्रॉन हमने निकाल दिया. Even though it is empty, but we had the fourth shell. And when you have the fourth shell, you will get all 4s भी मिलेगा आपको, 4p भी मिलेगा आपको, 4d भी मिलेगा अगर आपको चाहिए. If you need the 4d, you will get the 4d also. Okay, but in this case, do we need 4d? No, we have got all the 6 vacant orbitals, and then you can show something like this. All of these will combine. You have the 2 orbitals of d, then you have 1 orbital of s, and you have the 3 orbitals of p. So this is dsp2, and then again you will make these 6. 1, 2, 3, 4, and 5. Okay, now 6, all of these are vacant, and in this the 2 electrons that is being given, it is given by what? All of these electrons are given by NH3. Okay, so this is the dsp2 hybridization, and then you write the geometry. Octahedral. Now there is one more thing that you can write here, and sometimes they can ask you also. See, here the d orbital are the inner d orbitals. The outermost shell is what? 4s, but the d orbital that we are using is what? It is the inner d, that is 3d, and that is why you will also write this is inner orbital complex. This is inner orbital complex. Okay, so what are the steps that you need to follow? First of all, get the oxidation state. From the oxidation state, get the electronic configuration of that particular oxidation state. Then decide whether there will be pairing or no pairing. Pairing or no pairing. So ये step जो है ना आपका, this step will be given you. अगर आपको दिया हुआ है diamagnetic या paramagnetic, तब तो आप वहां पे लिख दीजिएगा because it is diamagnetic complex. If they do not give you whether it is diamagnetic or paramagnetic, then you have to use the information from crystal field theory. You will look at the ligand, and once you do the crystal field theory, you will understand that okay, fine, this ligand is going to do pairing, this ligand is not going to do pairing. Okay. So pairing or no pairing, that you can have the information, you can borrow that information from the crystal field theory. And then next is what? According to the coordination number, get empty orbitals. ठीक है, अकॉर्डिंग टू द कोऑर्डिनेशन नंबर गेट द एम्प्टी ऑर्बिटल्स, ऑक्सीडेशन स्टेट, इलेक्ट्रॉनिक कॉन्फ़िगरेशन, एंड अकॉर्डिंग टू द कोऑर्डिनेशन नंबर गेट द एम्प्टी ऑर्बिटल्स. Okay, so these are the steps that you need to follow. Only 4 steps for valence bond theory. Now, this section, pairing or not, no pairing, that we can decide either by, it will be given in the question. According, they will write something like this. There is diamagnetic and paramagnetic. If they are not writing diamagnetic, paramagnetic, then what you need to do, you need to borrow that information from crystal field theory. Okay, वो आ जाएगा. अभी हम आप लोग को बता देंगे कि कहाँ पे pairing होगा नहीं. Okay, but when we go to CFT, then you will look at the ligand and then decide yourself whether it is going to give pairing or no pairing. Done everyone is hello, me? All of you done?
Yes.
Right. And guys, if you can start, please start this one. Cobalt Fe6, sorry, cobalt F6, 3 negative. Start with the oxidation state. If you can find, please send on chat. All of you done, you
Yes.
Right, next. Oxidation state. X plus 6 into how much? What is the charge on fluorine?
-1.
-1 will be equal to
-3.
-3. So X will be equal to +3, right? Okay. Now B part is electronic configuration. So we have just done cobalt 3 plus. Tell me what is the oxidation state? Sorry, what is the electronic configuration? Cobalt 3 plus is outermost. Tell me guys. Cobalt 3 plus state ना. अच्छा कोई और नहीं बोलेगा और किसी को कुछ नहीं आ रहा है क्या? Yes, सारा, सलमान, सैफ, मीनाक्षी, मैथ्यू, खालिद, हिश्मा. इलेक्ट्रॉनिक कॉन्फ़िगरेशन बताइए. CO3 plus D5. कौन D5 है भाई? 3D6 लिखा है हमने. D5 कौन है ये? Who was D5? 4s0, 3d6. Okay, cobalt is 4s2, 3d7. 27 atomic number. Okay, once you have got the electronic configuration, आप यहाँ पे you will make this 1, 2, 3, 4 and 5. Stupid. Now here we'll have 6 electrons. 1, 2, 3, 4, 5 and 6. Okay, and the 4s will be vacant. ठीक है? Now you will write, since complex is paramagnetic, no pairing of electron must take place. ठीक है, अब तो आपके पास पेयरिंग ऑफ इलेक्ट्रॉन तो होगा नहीं. सी पार्ट अब क्या बचा? एम्प्टी ऑर्बिटल्स. हाउ मेनी एम्प्टी ऑर्बिटल डू आई हैव? टेल मी गाइस.
1.
हमारे पास कितना एम्प्टी ऑर्बिटल है? वी हैव ओनली 1 एम्प्टी ऑर्बिटल, राइट? एंड व्हाट इज द कोऑर्डिनेशन नंबर हियर फॉर कॉम्प्लेक्स? कोऑर्डिनेशन नंबर कितना है? व्हाट इज द कोऑर्डिनेशन नंबर गाइस?
-6.
कोऑर्डिनेशन नंबर. अरे कौन है, सो रहा है क्या आप लोग? व्हाट इज द कोऑर्डिनेशन नंबर? सैफ? हाँ सैफ,
Yes, sir.
कोऑर्डिनेशन नंबर क्या है? कोऑर्डिनेशन नंबर, ऑक्सीडेशन नंबर नहीं. Yes, tell me. Arey, what is the coordination number? Saf, you don't know?
I said -3. -3, sorry.
-3 तो ऑक्सीडेशन नंबर है ना. सैफ, कीप योर माइक ऑन. कोऑर्डिनेशन नंबर क्या है याद कीजिए. फर्स्ट क्लास में आप नहीं थे क्या?
No, sir.
ओहो, आपने नहीं पढ़ा अभी तक फर्स्ट क्लास को. आप लोग जब नहीं आते ना तो फिर आप थोड़ा सा कम से कम मैसेज कर दिया कीजिए. जस्ट अ सेकंड गाइस. Coordination number is 6. Number of coordinate bond it can make. Okay, so coordination number is 6. Now, if the coordination number 6, how many empty orbitals do we need? Tell me. How many empty orbitals do we need? We need dash empty orbitals. अरे कोई नहीं बोल रहा. How many empty orbitals do we need, guys? Yes, Astha, Heshma, Khalid, Minashi, anyone?
6.
5
है ना?
more orbitals.
हाँ, 5 more. एक हमारे पास है यहाँ पे और टोटल हमको 6 चाहिए. नाउ कहाँ से मिलेगा ये बताइए तो जरा. 4s तो है हमारे पास. What else do we have here? 4p होगा. हाँ या ना?
4P and 4D.
4p भी होगा, 4t भी होगा. We'll take 2 from the D. ठीक है. So यहाँ पे आपके पास this is 4s, this is 4. नहीं, ऐसे मत कीजिएगा. वेट अ सेकंड. फर्स्ट ऑफ ऑल इनको अलग अलग रखिए. And then you will have sp3d2, and since you are using this 4d, that is outer shell, outermost shell, so it will be outer orbital complex. And then you will just get this 6 together. 1 2 3 4 5 6. Okay, and all of this is given by fluorine. All of this is fluorine. Okay. Please write this down. After you're done, write some questions. तो यहाँ पे आपके पास हाइब्रिडाइजेशन हो जाएगा, sp3d2 कॉम्प्लेक्स हो जाएगा तुम्हारा, it will be in sorry, this will be outer orbital complex, and geometry will be octahedral. Okay, so give hybridization and geometry of the complex. H2O whole 6 3 plus. ठीक है. Second is FeCN6 3 negative. Nickel CN4 2 negative. Nickel Cl4 2 negative. चलिए, ये फर्स्ट वाला करके प्लीज सेंड द आंसर ऑन माय व्हाट्सएप. If you get stuck somewhere now, please let me know.
Sir, can you show the previous answer, last part again?
हाँ, sure. पहले ही लिखे आप लोग है ना, अभी बाकी 3 को छोड़ दीजिए.
We have sent you this.
Sir,
Yeah, Tanvi.
sir, for these questions you haven't given that it's paramagnetic or diamagnetic, and for
ठीक.
that we need the
Listen.
list, right? The
just a second, sorry. This will be paramagnetic diamagnetic तो नहीं देंगे, ठीक है ना, pairing or no pairing. Okay, so for the H2O case, please write no pairing. Cn there will be pairing, Cn there will be pairing, and for Cl there will be no pairing. Yeah, correct. Yes, answer that is right. Very good. Yes. Saf, correct. Very good. Krishna, looking at your answer. Yes, correct. Very good. हाँ, देखिए पैरामैग्नेटिक हमने नहीं कहा है ना खालिद. I mean, it is paramagnetic, that is true, because unpaired electron होंगे वहां पे. And electronic configuration आपकी सही नहीं है खालिद. You have to remove 3 electrons ना. देखिए, you have to remove 3 electrons. P3 plus Matthew. ठीक है, that is fine. But please denote that all of those electrons are coming from water, H2O. ठीक है ना?
I wrote it down.
हाँ, yeah, that is true, but वो 6 electron तो नहीं है, वो सारे, I mean, it is 12 electrons from H2O, and also like make arrows and all. Don't give the examiner any chance of deducting any marks, okay? And that
Okay,
is why
sir.
it is preferable that you give the electrons of ligand as cross, okay? And the electrons
Alright,
of
sir.
the metal atom that is there, it should be in like half arrows and all. Okay, so just to discuss it a bit here, iron will be Fe3 plus, and for Fe3 plus you will have 4s0 and 3d5, right? Because Sakti Vikraman man is 25, Feco is 26. 26 means 4s2 3d6. Now here we have 1, 2, 3, 4, and 5. These have 1 electron each. And since there is no pairing, we cannot pair this up. And we have the 4s. And then 4s, the 4p, and the 2 orbitals from 4d will be used. Okay, and all of these will have the electrons from water. So my hybridization will be sp3d2, and the geometry will be octahedron. Yes, correct. Asta, this is right. In CN, you will see that pairing is taking place, but still it is going to be paramagnetic because it will have one electron that is going to be unpaired. Okay. So remember that. And that is why valence bond theory is not a very right theory. It fails most of the time, I would say. Even if we have the paramagnetic or diamagnetic nature, it cannot correctly predict whether it is going to be sp3d2 or d2sp3, what is going to be the geometry here. Okay. Okay, till here nickel one is fine. What? How did that doesn't make sense now? आप वो 5 इलेक्ट्रॉन को पेयर तो कीजिए खालिद. एम्प्टी ऑर्बिटल्स वो भी नहीं लिखा आपने. खालिद, why are you in a hurry? स्टेप्स प्लीज सारे स्टेप्स फॉलो कीजिए. हमने जब यहाँ पे बिल्कुल साफ साफ इस तरह से लिखा है सारी चीजों को, तो फिर आप लोग क्यों नहीं लिख रहे हैं? You'll write since the you will say that since pairing takes place, आप पेयर कीजिए यहाँ पे, and then you show that these are the DSP, D2, sp3, and so on. Second one is not right, Khalid. Okay. Hishma, हाँ ठीक है, pairing takes, very good Hishma, this was very right. ठीक है, all of these are correct. आप एक सेकंड, निकल में, हाँ, yes, correct, correct, very good. Asta, nickel one is also right, very good. Waiting for others now. FeCN6. So again, here also Fe will be what? 3 plus only, right? Because it is what? -6 and -3, that will be +3. Okay, so Fe 3 plus 4s0, 3d5. सबसे पहले one, two, three, four, five. The 4s is as it is, right? This is 3d, this is 4s. Now pairing takes place. One, one, two, three, four, and 5. This will give you D2sp3 and then आप यहाँ पे भी ऐसे कर सकते हैं, क्रॉस कर दीजिएगा. They will understand that these are filled by ligands. ठीक है, these are filled by ligands. यहाँ पे जो हमने पेयरिंग वाला लाइन लिखा है ना, यहाँ पे if you do crystal field theory then you just need to write Cn negative is strong field ligand, therefore pairing will take place. So this line you just need to add whenever you are doing for whenever you're going to write the hybridization, explain the hybridization from valence bond theory. Okay, और कुछ आया मीनाक्षी? FeCN6. हाँ, ये देखे ना 4s आप पहले क्यों लिख रहे हैं? D2 D का ठीक है, 2 इलेक्ट्रॉन 2 ऑर्बिटल्स D के एंड फिर 4p रहेगा. प्लीज ऑलवेज रिमेंबर दिस ना, 4p is always there for you. ठीक है, 4p is always there for you. If you have 4s, 4p is there. ठीक है, दिक्कत ये है कि आप लोग असल में ना वो लिख नहीं रहे हैं चीजों को. कोऑर्डिनेशन नंबर 6 है, वी नीड 6 एम्प्टी ऑर्बिटल्स. जैसे 6 आएगा आपके दिमाग में तो आप ये खुद लिखिएगा. थिंग्स इज दैट यू कैन राइट ऑल ऑफ दीज थिंग्स, जो कम से कम आता है आपको, कोऑर्डिनेशन नंबर एंड ऑल. अच्छा, please do these two, nickel and Cl, and then send me. Yes, हिश्मा बहुत सही, very good हिश्मा, this is correct. ठीक है, तो यहाँ पे हिश्मा we have written ना pairing takes place. So once we do the crystal field theory, then you will write since Cn negative is a strong field ligand, pairing will take place. Okay, that's it you are going to write, and then you are going to do the same thing whatever we have done till now. करेक्ट आस्था, वेरी गुड. Cl नेगेटिव के लिए हम लोग लिखेंगे since Cl negative is a weak field ligand, therefore pairing does not take place, and then we'll do the same thing that we are doing right now. ठीक है, ये देखिए ये आपका ना 2022 में जो टॉपर का पेपर था. So you just need to write something like this. This is how you need to answer. बहुत ज्यादा लिखने की जरूरत नहीं है यहाँ पे. Okay, as the ये line बस what see electronic configuration. ठीक है, oxidation state निकाला Fe3 plus उसका electronic configuration, and then you show that it is going to be pairing or no pairing and so on. Geometry and shape are going to be same in coordination compounds. Astha, you are done now, so I'm not going to teach anything extra here. So if you want, you can leave.
Okay, sir. Thank you, sir.
Thank you. ठीक है सैफ, यहाँ तक तो CN नेगेटिव तो समझा दिया हमने। CN नेगेटिव में देखिए फिर आगे। ओहो, इलेक्ट्रॉनिक कॉन्फ़िगरेशन ठीक है, ठीक है। पेयरिंग क्यों नहीं कराया? पेयरिंग होगा ना सैफ? सैफ
यस सर।
पेयरिंग कराइए ना, पेयरिंग कीजिए फिर। अब स्टेप्स ही भूल जा रहे हैं आप लोग तो। ये स्टेप्स हैं, ये सारे के सारे ABCD ये होने चाहिए, ठीक है। ऑल ऑफ दीज शुड बी प्रेजेंट।
Yes. So which question you are talking about?
आई एम टॉकिंग अबाउट द FECM। अभी आपने FECM 6 का भेजा ना सैफ?
I actually sent you all 4.
अच्छा, ये सेंट में ऑल 4। अच्छा, हमने CN, अच्छा उस टाइम तक आया नहीं होगा, ठीक है। कोऑर्डिनेशन नहीं, FECM 6 में पेयरिंग नहीं, पेयरिंग तो आपने कराया नहीं, लेकिन ना देखिए। अच्छा, बाद में कराया आपने, ठीक है, ठीक है। ओके, CL में आपके पास ठीक है। अच्छा, sp3 होता है ना तो टेट्राहेड्रल होता है। ओके, आपने देखा था सैफ? When it is sp3 then it is tetrahedral ना, तो ज्योमेट्री आपने गलत लिख दिया वहां पे। बाकी सब सही है, ठीक है, बाकी सब सही है। लेकिन थोड़ा ध्यान रखिए, देखिए आंसर आपने इस तरह से लिखे, राइट इट लाइक दिस। ओके, ठीक है। And you just show the ligands electron like this. Otherwise everything is correct, sir. एक आप वहां पे करेक्शन कर लीजिएगा कि sp3 आपका जो होगा that is going to be tetrahedral and not square planar. Otherwise everything is correct. Very good. अच्छा, rest of you guys, you all also please send me the answers, ठीक है ना? आप please आंसर भेजिए इन दोनों का। I'm going to end the class right now because it's Maghrib here, and then